Section 11.5 is volumes of pyramids and cones. So, the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. So if you remember, for a prism which goes straight up, it was the area of the base times the height. Now that I'm doing a pyramid, which is a central point, this is 1/3 of the height of the prism. So 1/3 the area of the base, whatever the base is, square, rectangle, pentagon, whatever, times the height, and then we just take 1/3 of it to get a pyramid rather than a prism. So let's do one. What's the volume of a square pyramid with base edges of 40 and a slant height? So again, my pyramid goes up to a central point above the middle of the base, and they tell me that the edges are 40 and the slant height along one of the faces is 25. Well, I need the height of the actual pyramid. So drawing a right triangle to get my slant height, or to get my regular height, sorry, I have the slant height, that's going to be 20, half of the diameter. So 20 squared plus h squared equals 25 squared using Pythagorean. H squared is 625 minus 400, 225, which is 15. So that's my height. That's my central height of the actual pyramid. So the volume of the pyramid is the area of the base. In this case, it's a square. So 40 squared times the height, which is 15. And don't forget, we're taking 1/3 of that. So that's 1/3 of the math today, 1600 times 15. So that's 1600 times 5. 1/3 of 15 is 5. And we get 8,000. And that's going to be cubic feet. So again, find the actual height of the pyramid, not the slant height, and then use your formula. Okay, the volume of a cone, very similar. If we have a cylinder and goes straight up, it's the area of the base times the height. When we have a cone, it's 1/3 the area of the base, which is a circle, times the height. So same idea as a pyramid. Okay, a pile of sand is a right cone with a height of 12 feet. A right cone means that the height is perpendicular to the base. So that's a height of 12 feet, and the base is 14, which means my radius is 7. So the volume is 1/3 the area of the base times the height. So that's 49 pi times 4, which equals 196 pi. And if you want to approximate that in decimal form, 615.75. This again was feet cubed. So the last thing I want to look at in the video, and this is a pretty quick lesson, is an oblique cone. An oblique cone is where the point of the cone is not central over the center. So an oblique cone, and I don't want that to look like a right angle. Let me move it over just a little bit. So an oblique cone, the height does not come down in the center, but the height is going to be the same. Remember our theorem about how a stack is, whether a stack is crooked or straight, it doesn't make any difference. Height and a diameter of 30. So again, the volume is 1/3 the area of the base, pi r squared, times the height. In this case, it would be 15 squared times 5. And if you plug that all in, we get 1875 pi. And again, approximating that to decimal form, we get this decimal. And that, again, is feet cubed. So a couple of new formulas is it, and just making sure that we know the difference between the height and the slant height of something and use that to find our volumes. That's it.